Good afternoon, Professor. This is Jamar Sanders from your Forensic Science 106 class. And right now I am completing the separating mixtures lab activity. And the method I have chosen is the induced salt precipitation, otherwise known as salting out. To get started, I'm going to fill this bottle a third of the way to the top with water, tap water. After that, I am going to pour this isopropyl alcohol, 91% isopropyl alcohol, inside of the water bottle. After that, I'm going to shake this bottle up and count to 250. Just to make sure the tap water and the isopropyl alcohol completely mixes together. And the way this works is that they both have similar chemical buildups, both containing OH molecules. And once I add the salt will combine with the isopropyl alcohol within the mixture, which is now a mixture of alcohol and water, and it's no longer water and alcohol, although it is at the same time. I have to keep shaking just to make sure it completely mixes together, otherwise it will not work. And how I know that it completely mixes together within the bottle is that there will be no foam formed at the top, and it won't be all frothy. So I have to keep shaking. It worked earlier. I did a trial, and I found out that I wouldn't be able to see the alcohol separate from the water once I added the salt. And so I knew that I needed to use a disposable pipette and some red fabric dye to extract and then place inside of the bottle with the alcohol, water, and the non-iodized sea salt. And I choose non-iodized sea salt, as you can see here, because iodized salt, or the iodine within the iodized salt, would interfere with the separation process. Okay. As you can see, it is not foamy or frothy. There wasn't really no bubbles within it. So now I can go ahead and add the sea salt. And I have to add a considerable amount of sea salt within the contents of the bottle. Pretty much all of it. Probably this much, and what will be left is this amount here right above the barcode. Okay, this is the combination of alcohol and water. It's now one mixture and they're combined together. And now I am pouring the pure ocean non-iodized sea salt within the bottle. Okay, I poured in a little bit less than I said at first, but this is the amount I had earlier when I did a trial experiment to see if it would work. I'm going to rinse off the salt from the outside of the bottle. Then I'm going to shake up this mixture. It counts to 250 again. You can go ahead and fast forward the video, Professor, but the shaking process takes a little bit of time, probably about 1.5 to 2 minutes. Again, this takes a little bit of time. Okay, now a considerable amount of the salt has been dissolved within the contents of the bottle. Excuse me. The alcohol is less dense than the water, so the alcohol will sit on top of the water within the bottle, which is not completely alcohol, but just a mixture of about, it started off at 91% isopropyl alcohol, and now it may be about 70% isopropyl alcohol, or maybe even less, about 20% isopropyl alcohol, but the alcohol is still less dense than the water that is on the bottom. And so now I have the red fabric dye that I mentioned earlier, and I've already extracted some from the bottle with the disposable pipette, and I'm going to place a few drops of the red fabric dye within the bottle. 1, 2, 3. Then I'm going to stir it a little bit at the top, just to make sure that I can see that the water, that the isopropyl alcohol on top actually turns red, so that you may be able to see as well. And if you look within the bottle, you can see some of the red fabric dye sitting at the bottom of the alcohol that sits on top of the water, which lets you know that they have been completely separated. And there is salt on the bottom. It is clearly distinguishable. You may not be able to see that the water on top is a different color that the alcohol on top is a different color from the water at the bottom, but I can tell that it's a pinkish color, but there is a bit of red fabric dye that sits at the bottom of the isopropyl alcohol. And yeah, Professor, that is the induced salt precipitation or salting out method that I use for the separation or separating mixtures lab activity. Thank you.